Everybody, this is Coach Allen. We are in the six weeks, week 4 of online learning in geometry, and our topic is special right triangles. I completely messed up those videos. There were just too many errors to where I just felt the need to redo the video instead of confusing you guys. Plus, I'll use this stuff again in the future and share with some of my peer teachers. But let's jump right into it. This first video of 4 is going to be a recap of simplifying radicals by multiplying and dividing. Why did we have that last week? Well, because we have radicals on sides of these special right triangles, and so when we multiply and divide to go from one side to the other, we're going to have to know some special rules. So again, this is a recap. I am going to zoom through it. You are expected to either pause and review if you already did the lesson from last week, or you're going to have to go back and watch it. And I deleted it off of the assignment, and I'm going to re-add it to this week so that you know exactly where to find it. And there goes my dog acting psychotic. Okay. All right, so last week, this is the link. It's on YouTube, and it's broken into 3 sections. I couldn't do 3 separate videos. It didn't let me cut it up, so it's tagged. So in YouTube, if you click the number that's hyperlinked, it'll jump to that section of the video. It talks about what perfect squares are. Pause if you need to look and recap those. Talks about the square roots of perfect squares. So going back to what number times itself gave you those. Again, pause if you need to see this. So we had some examples to show you what happens when you multiply a constant term or coefficient, with its radical, or 2 radicals that are the same, or radicals that are different that will not reduce. Pause if you need to review those. Again, it's in the video, the last video. Then we talked about where you could possibly simplify, and I specifically wanted you to understand how to factor out a square number. That way you can take the square root of that, and then what other factors under the radical were left will stay. Well, the only thing I'm going to add is if you didn't see that square number that was a factor, then you can break that number under the radical down, kind of like prime factorization. And when you're multiplying, it doesn't matter the order. You find 2 radicals that are the same, and that's actually a square number under the radical. So you see 2 numbers under the radical the same, you pull out 1 in front of the radical. And you could pause these to see that. And then these 2 examples are the same. Oops, let me go back. You can pause this to look at these. Again, these are the exact same problems from last week. All I did was break down using all the prime factoring versus pulling out a square factor. Okay, more recap. When you are multiplying by a when you're dividing by a radical, we end up multiplying by the number 1 to get rid of that radical because we can't have it in the denominator. So we went through examples of this last week. Oops, sorry, going a little too fast. Here was a shortcut to understand. Slide the radical up, pull the number out. Go back, watch the video. Example showing how you simplify. Another example. Another example of reducing a radical over a radical. When you get 1 as the numerator of that fraction, a whole number. And when you get 1 as the denominator of that fraction. So again, last week's video. And here were those answers to last week's. Okay, so now here's the new stuff. This first video is actually almost over. The recap was longer than what the real video is going to be because it's not going to take that long. So write your answers down as we read through these. So we're talking about a 30, 60, 90 special right triangle because the measure of the angles in that triangle are 30 degrees, 60 degrees, and 90 degrees. When you look across from that angle, the side that would close off the angle and make the triangle is reflective of that angle measure. So it's the smallest angle, that's the small leg. This is a medium angle, it's the big leg. Now legs are the 2 sides that make the right angle. The hypotenuse is always the side across from the right angle, which is the largest. If you didn't draw this, pause it and draw it. So now, question straightforward. How do you identify the short leg? It's across from the 30-degree angle. That's A. How do you identify the long leg? It's across from the 60-degree angle. That's B. And how do you identify the hypotenuse? It is across from the right angle. So there is a formula, well, a ratio of sides on your formula chart from smallest to largest for a 30, 60, 90 triangle. So what is that ratio? It is x radical 3, and 2x. Okay? Be careful. A lot of people want to think 1, 2, 3. No. That radical is that radical 3 is on the leg, and just remember, 2's are always on the hypotenuse. This is going to come in later. So when I label the sides, now I see the whole picture. Okay, I drew arrows to show which angle corresponds with which side. So go ahead and add those sides to the label. To the triangle. Pause if you need to. Moving forward. So answer those 4 questions in All in Learning Now. That is the end of video 1.